Hey guys, it's me, Miss Escamilla. Today, the homework that you need to get done are problems 7, 8, 9, and 10. So you have 4 problems today that are due tomorrow on Thursday, whereas the last couple of nights we've had 3 problems. So let's get busy. The first problem that you guys are going to work on tonight, number 7, is regarding using models to compare fractions. So yesterday in our homework, we used a strategy called the butterfly strategy to compare fractions, but we've also learned how to compare fractions using picture models, whether it be a number line model or a rectangle divided into equal parts to compare fractions. So when we're comparing fractions using models, for example, if I wanted you to compare, let's say 4/5, well, let's say, actually, let's do 4/6, and compare that to a half using models, then I would take the 4/6 and I would create a model. And because our denominator is a 6, that's the total number of equal parts that I need to separate this model into or divide it up into. And the way I do 6 is I usually divide it into 3 equal parts and then cut those in half. And so each one of those pieces represents 1/6. There's a total of 6 pieces. Our numerator is a 4, so that was going to represent the number of pieces we need to shade. Okay, so if I want to compare this 4/6 to a half, then I need to draw another model that's the same size as this model in order to be able to make an accurate response. So I'm going to draw another model that's about the same size as this one. I'm going to do the best that I can. And it's about the same size. And because our denominator is 2, that I'm going to divide this model into 2 equal parts. This is going to represent a half, and this is representing a half. So in our model here, I should need to shade in 1 out of 1/2. So I'm going to shade in one of those parts. Okay. Now, when I look at the models, I can tell, and this one's it's pretty close, but I can tell that the amount that I have shaded on this is a tad bit bigger than the amount I have shaded, a tad bit larger than the amount I have shaded over here. They look pretty close. This one almost looks like a half, but it's a little bit more than an actual half. So using this model, I would say that 4/6 is greater than a half. I also know that I also know this because if I have 4/6, well, think about the number 6. What's half of 6? Well, half of 6 is 3. Okay, so if I were to have 3 out of 6 parts, if I have 3 out of 6, well, 3 is half of 6. So that would tell me that 3/6 is exactly a half. So if you have 4/6, that tells us definitely 4/6 has to be greater than a half using a model. Okay, so when you're trying to decide on this problem which one is greater, 1/2 or 5/12, think about the amount that is shaded, okay, in these two models. You could also compare this using a number line. Okay, so if I were to take my problem, 4/6 and a half, I'm going to create 2 number lines of equal length. Have to be equal length for it to make sense. And the first number line, I'm going to divide it into 6 equal parts. So I have 1, 2, 3, 4, 5, 6 equal parts. I'm going to go ahead and put a line here and a line here. Okay, this would represent 0. This would represent 1/6, 2/6, 3/6 or a half, 4/6, 5/6, and 6/6 or a whole. And 4 6 would be about here. Okay? Now my next model, I'm going to create it into 2 equal parts because our denominator is 2. So here's an equal part, and here's an equal part. So this would be 0. This would be the halfway point, and this would be 2 halves, or we could say 1 whole. Same thing. And if I put a dot where 1/2 would be, my dot would be here. So just looking at these two models, I can see that 4 6, the dot goes further to the right than it does for 1/2, which would signify that 4 6 is, again, greater than a half. Okay, so this is the information that you need to know in order to help you to solve this problem in deciding whose response was correct when they were comparing 5/12 to half, to these 5/12 to half. Whose model was correctly represented that? Okay. The second problem for homework tonight at number 8 is requires our skill of adding and subtracting decimals. So you have to decide whether this is an addition problem or a subtraction problem. But the key to adding and subtracting decimals is just to simply line up the numbers correctly. So if I were to give you $4.36 and I wanted you to add it to $3.75, the key is to make sure that you are adding up the place values correctly. So this is my ones place, so I need to line it up with my ones place. I line up my decimals. This is the tenths place. I have those correctly lined up. And this is the hundredths place. I have those correctly lined up. So when I add those, 6 and 5 make 11, 7 and 3 make 10, plus 1 is 11. I carry my 1. And then I'm going to go ahead and bring my decimal point down now. So I directly down underneath the 2 decimal points up top to make sure I don't forget that. And then when I find the sum of 4, 1, and 3, that makes 8. So my total would be $8.11. If we were adding. Now, if we were taking away and subtracting, you would need to make sure to have the greater amount on top, which $4.36 is definitely greater than $3.75. And to, again, make sure that you have your correct place values lined up with the correct place values. So 6 minus 5 is 1. 3 minus 7, you can't take away a larger number from a smaller number, so you have to go next door, get one more, which means you're borrowing from that 4, you're regrouping. That 4 now becomes a 3 because he's lending 1 to this 3. Here's the 1 that it lends it. So now we can subtract 13 minus 7, the difference is 6. Bring my decimal point down, 3 minus 3 is 0, so you're left with 61 cents. Now, so that's how we add and subtract decimals. Now, the only thing that you might want to be also thinking about, though, ladies and gentlemen, if you get a problem and where if you're expected to add a whole number such as 37, there's no decimal point, and I'm wanting you to add, let's say, 1 and 45 hundredths, well, this number is a decimal and this one is not. So this is just a whole number. So we need to make sure that if we're going to add these two together, both numbers need to be decimals. So that means we need to take 37 and turn it into a decimal by simply adding a decimal point after it and a 0 in the tenths place and the hundredths place, because adding zeros does not change the value of that number. Then I can take my decimal 1 and 45 hundredths and add it to this, because now they're both decimals. The 1 is in the ones place, so I would need to line it up in the ones place. The decimal point would go directly underneath this decimal point, and then 4, which is in the tenths place, would go directly under the 0 that's in the tenths place. The 5 that's in the hundredths place would go directly under the 0 that's in the hundredths place. So now if I wanted to find the sum, I would just add 0 and 5 make 5, 0 and 4 make 4. Bring your decimal point down, 7 and 1 make 8, 3 and 0 make 3. For an answer of 38 and 45 hundredths. Make sure that both numbers are turned into decimals in order to be able to be successful on that. Okay, on number 9, we are generating equivalent fractions. And so we can generate equivalent fractions. We learned 3 different ways to do this. We learned how to do this using a model. We learned how to generate equivalent fractions by multiplying. And we learned how to generate equivalent fractions by dividing, which we can also call simplifying. Okay, so in this problem, it's showing you a model. But the question's asking you how else could she demonstrate that 4/8 is equivalent to 1/2. So we could use multiplication and we could use division to generate an equivalent fraction. So for example, if I wanted you to generate an equivalent fraction to 3/6, okay, I could generate an equivalent fraction by multiplying the numerator and the denominator by the same number. And when I do this, 3 times 2 is 6, 6 times 2 is 12. That means that 3/6 is equivalent to 6/12. Okay? So, but that would be using multiplication. I could multiply by any number. I could do times 3 and get 9/18. And that would mean that 3/6 is equivalent to 9/18. You can multiply by any number and generate an equivalent fraction. Okay? However, you can also divide to generate an equivalent fraction. So if I were to have the same fraction, 3/6, I could generate an equivalent fraction by dividing a number, dividing the numerator and the denominator both by a number. But it has to be a number that both the numerator and denominator can go into both of these. So I know that 3 can go into 3, and I know that 3 can go into 6. Therefore, I'm going to take that 3 and divide it by 3. And of course, what you do to the numerator has to be done to the denominator. So I'm going to divide 6 divided by 3. And when I do this, 3 divided by 3 is 1. 6 divided by 3 is 2. So I have determined that 3/6 is also equivalent to 1/2 using division. Okay? So with that being said, think about how you could use either a different strategy. In this one, they're showing me a model that 1 out of 2 parts, or 1/2, that's the same amount that is shaded as is shaded right here, 4/8. Same amount shaded, they're equivalent. But how could you show that these 2 fractions are equivalent in another way? Okay. And then finally, the last problem is using our learning standard of adding and subtracting fractions. So if I am starting off, if I'm adding fractions, then if I have 3/5 and I want to add a 5th, then I simply add the numerator. 3 plus 1 is 4. And the denominator always stays the same because that's the number of equal parts that an object has been divided into. We're not adding a number of equal parts. We're adding just the parts in question. So that would be 4/5. If we're subtracting, though, it's the same concept, except this time we're subtracting the numerator. 3 minus 1 is 2. And if the denominator stays the same, so our answer would be 2/5. Okay? Now, the key in adding and subtracting fractions in 4th grade is knowing the model that represents that, a picture model. So in this problem right here, how could you use a picture model to represent that? Okay? And so I want you to think about when you're doing the problem today, the question is saying that Sam is mowing his lawn. So I'm assuming that this is his lawn. He's got to mow this whole thing. But he's already mowed 3/5 of the lawn. He's mowed this part, and this part. So what would be the fraction for the lawn that he has left to mow? So if he's got to mow this whole thing and he's already mowed this much, how much does he have left to mow? And I want you to be thinking about how you could use the picture to solve the problem. And how could you use an equation to solve the problem? Now be careful, because I know some of you are thinking, well, it only gives me one fraction, 3/5. How do I know what the other number is I should be adding or subtracting. Well, if he has to mow the whole lawn and he's already mowed 3/5, what would be the fraction for the whole lawn? What would be the fraction for that entire lawn? The fraction. How could we take that number 1 and make it a fraction? And that tells you your other number in your equation. Okay, so be prepared to explain how could you use the model to answer this question, and how could you use either an addition or a subtraction problem to solve this problem. Okay, I hope this helps. Good luck on your homework, guys. Thanks for tuning in. I appreciate it.